If you've ever worked with data, you know the cycle. You've got to get it in, you've got to do something with it, and then you've got to send it back out. Well, today, we're going to build the ultimate blueprint for mastering that entire data lifecycle in Pandas, from the very beginning to the very end.
Oh yeah, let's be honest. This is where it all starts, right? A folder just jam-packed with messy files, all different kinds, totally jumbled. The big question is always the same. How do we take this chaos and turn it into a clean, structured, and managed dataset inside Pandas? We're going to solve that right now.
So here's our game plan. We'll kick things off by talking about that messy to managed journey. Then I'll introduce you to what I call the 3 pillars of getting data in and out. After that, we'll dive into how to ingest and verify your data, how to store and transform it, and finally, we'll put it all together in one seamless workflow.
Okay, first things first, let's really nail down this core challenge, making that leap from messy to managed. This is all about building a solid bridge from those raw, chaotic files into a clean environment where you can actually start doing your analysis.
So how do we build that bridge? Well, it's simpler than you might think. It really just comes down to 3 fundamental concepts. Think of them as the 3 pillars of your data I/O toolkit.
You know, data import and export can seem really complex from the outside, but it really just boils down to these 3 foundational pieces. You need the file name, a function to read the data in, and a function to write the data out. Seriously, you master these 3 things, and you've basically mastered the entire process.
Pillar number 1, the file name. It's super straightforward, but it is absolutely critical. Think of it like the street address for your data. You have to tell Pandas exactly which file you're talking about.
Next up, Pillar 2 is the read file type function. This is your in-door. It's the command you use to pull data into your coding environment. Anytime you want to open a file and take a look, you're going to use one of these read underscore functions.
And our final pillar is just the other side of the coin to file type. This is your outdoor. It's the function that pushes your clean process data out of your environment and saves it to a brand new file. It's basically your save as command.
All right, we've got our toolkit. Now let's get practical. We're moving on to ingestion and verification. This part is all about getting the data loaded up, and just as important, checking it twice to make sure it arrived in one piece.
Let's look at a classic. You'll see this everywhere. pd.readcsv, stock.csv. So let's break it down. That pd at the start, that's just the popular nickname for the Pandas library. Then readcsv, that's our pillar. That's the core function telling Pandas to read a CSV file. And of course, stock.csv is our file name, telling it exactly which file to grab.
Okay, so you run the code and no errors. Awesome. The data's loaded. But is it actually correct? Did it come in looking the way you thought it would? How can you be totally sure without having to scroll through, a million rows of data?
And the perfect solution is the head function. It's so elegant. Instead of trying to look at the whole giant data set, head just gives you a safe, quick snapshot of the first few rows. It's the best way to immediately verify that your columns look right and that your import was a success.
Okay, our data is in and we verified it's looking good. Now it's time for the second half of the data lifecycle, storage and transformation. This is all about saving our progress and, get this, even changing the file's format.
Exporting your data frame is just as easy as importing. Check out this command. df.toCSV, newstock.csv, index equals false. So first, you call the toCSV function. Simple. Then, you give it the name for the new file, and here, this is a crucial pro tip. That index equals false part, it's super important. It tells Pandas not to write its own row numbers into your file, which keeps things nice and clean.
And right here, you start to see this perfect symmetry, don't you? The read functions bring data in so you can see it and work with it. The to functions send that data back out so you can save your work. It's just a really elegant and simple loop. Now, of course, data comes in all sorts of flavors. The ones you'll run into most often are CSVs, which are kind of the universal standard for tables, Excel files for when you're working in a business setting, and JSON, which you'll see a lot with web data that has a more complex structure. And this is where Pandas becomes an absolute powerhouse. It acts like a universal translator for your data. Just look at this. You can use a read function to bring in one kind of file, say a CSV, and then immediately use a to function to save it as something completely different, like an Excel file. It's a format converter built right in, and it only takes 2 lines of code.
Okay, we've covered all the individual pieces of the puzzle. Now, let's snap them all together and walk through a complete end-to-end workflow from start to finish.
Here it is, the entire data lifecycle in 4 simple steps. Step 1, generation. We start by creating some data from scratch, in this case, a little table of student names and their marks. Step 2, export. We immediately save that table to a CSV file using toCSV. Step 3, verification. We then read that same file right back in with readCSV and use head just to be sure it's saved correctly. And finally, step 4, conversion. We change its format, saving it as an Excel file with toExcel. That's it. That's the whole loop.
If you remember just one thing from all this, let it be this simple idea. Import helps you to see data before you start. Export helps to save data after you finish. That's it. That's the fundamental rhythm of all data analysis. So, there you have it. That's the complete blueprint for importing, verifying, and exporting your data using Pandas. You literally now hold the keys to the entire data lifecycle. So the only question left is, what are you going to build with them?